before passing to the next example, I want to show you that we can use person type attribute with the index by clause. Let's change and see. Index by employees dot email person type. Let's clear up and run again. Pretty good. It all works fine. Until now, I showed you many different usages about the associative arrays, both with true and false usages. But there is something important that we need to use with collections, using with records. Actually, we need to use the records with the collections. Now, let's start with the easy one, the %row type attribute. Let's simply change the code then. Type elist is employees. I'm clearing and writing row type. Employees %row type. Now, as we know that row type attribute creates a record type based on the related table. Now we have a type that has a record with the employees tables type. So we can add many values into one row in an associative array. Now we have a list of records. It is pretty much the same as a table, isn't it? Yes, and because of that, they also call associative arrays as inline tables. Now let's change our code a bit and use this record. Now select all the columns into amps x. Now, as we know that row type attribute creates a record type based on the related table and of amps id x dot first name and amps idx dot last name is idx dot email. Let's change this and write amps idx dot email. Now let's run and see if it works. We had an error. Let me check expression of a wrong type, line 10. Oops, we have forgotten to delete here. So I am deleting here and clearing up and run again. As we can see, pretty fine. We could get all the data of an employee into a row in our array, then the next, and so on. So we had all the data of the selected employees and could iterate on it. Did you realize something? Although I did not change the index by type, it worked fine. Because as you can see, I used numbers as the indexes, but it is accepted as string. I mean, the index is implicitly converted to characters and used. No problem such a use. Now, we could easily use the records with row type attribute, but with row type, we got all the data of the employees and most of them are not used. We used only 3 of the columns. The rest is unnecessary and keeps a room in the memory. No need that. So we can create our own type and use it too. Let's see that. First, let's create our record type. Type e_type is record. And let's say first name employees dot first name person type. Now let's copy that. Now last name employees dot last name person type. Now email employees dot email person type. Now we need to use our new type name instead of our row type. So I simply write e_type in here. Now we need to change the star with the related columns with the same order of our record type. Otherwise we will get an error. So I write first name, last name, and email into the amps X. Good. Now let's run it. We have a misspelling, I think, in here. Let's add a semicolon and clear up and run again. As we can see, no problem. We can use records with both ways with the associative arrays. Actually, we can use it with the other collections too. The usage is all the same. Great. Now we know how to use records with collections. So let's see how to delete the rows from the associative arrays. It's pretty the same that we learned in previous lessons. I simply write amps.delete and the index is 100. The index 100 is Stephen King, as we can see in here. Now let's run it. As we can see, Stephen King has gone. We deleted the index of 100, so Stephen King is deleted. Besides, we can give a range into our delete function so that we can delete a list of our associative arrays based on a given interval. Let's see that. amps.delete 100, comma, and 104, for example. Let's run it. As we can see, the employees whose indexes are between 100 and 104 are gone. Pretty simple. Now, we said that we can go back and forth in associative arrays, but up to now we only went further. Now let's print our array from the last to the first. To go back, we use prior function. Let's see that. Let's delete here. And idx is equal to amps.last. And in here, idx is equal to amps.prior. Now let's run it. As we can see, our list is printed from the last to the first. It's so simple. You may need it somewhere. Great. Now let's make another example and finish this lecture. Let's create a new table named, for example, employees salary history with no data. Consider that we are inserting the data of the employees with the salary increases in each month. So let's clear the worksheet and create our table first. Create table employees salary history. Select all the columns from employees where 1 is equal to 2. Let's run it. Now let's add a new column for the insert date. Alter table employees salary. Let me copy that from here. Employees salary history, add insert date, and the type is date. Okay, let's check if we did correct. Select all the columns from employees salary history. As we can see, our table is ready with no data. Now let's write our code then. Declare. We will create our type first. Type e_list is table of employee salary history, %row type, index by PL&S integer. Now let's create our variable and the index variable. amps e_list and idx PL&S integer and our begin keyword. Now let's create our loop and the select into clause. For x in 100 ... 110 loop and select e dot star comma, let's say 01 dash June and 20. into amps x from the employees, and the alias is e, where employee ID is equal to x. Now, since our new table has one more column, I used an alias e and e dot star and a static date for the new column. You know that in your SQL lessons. So let's continue. And loop. Now we will traverse the array. So I write idx is equal to amps.first, and now our while loop, while idx is not null loop. Let's say we will increase the salaries by 0.2%. So I write amps idx dot salary. Let me copy that. Salary is equal to salary plus, again, salary times 0.2. Now let's make our insert. It's pretty same with the way that we learned in records lecture. So I simply write insert into employees salary history values amps and idx. We know that there is a record of employees salary history type in our array, so that we could directly insert the data into our table easily with using the associative array. You can see that pretty clear and simple insert code. And since this is a loop, we will be inserted all the rows of the array into our table at the end of the iterations. Perfect. Now let's make our dbms output to show that they are inserted. I simply write dbms output.putLine. Let's say the employee amps idx dot first name. Let's come here, is inserted into the history table. Now we need to take our array index further to iterate with the next one. So I use next function. We come in here and write idx is equal to amps.next idx. And loop and keywords. Now let's run it. As we can see, the message says that these employees are inserted into our table. Let's see if they are inserted. Let's query our this code. As we can see, we could successfully insert the values that we got from another table. We got the values, added a new value, updated the variables in it, then inserted into the table. Actually, that is pretty similar with the things that you will do in your PL/SQL job. You get some values from database, take it into variables or records or collections, then modify them, then store into the database again. This is what we do in general. So do not think that this example is not enough to have you do your job. All the examples on the internet seems pretty much like to this one, because how you improve this code is totally up to you about what you need. Maybe you will have thousands of codes, but not much different than what we do in this course. So I think this is enough for the associative arrays. We learned everything that we need. So this is the end of the lecture. See you in the next lessons.